Hello, this is Mr. Collier, and today we're studying theoretical probability and sample space. So here is a formula for theoretical probability. The probability of an event happening, probability of an A, is the number of favorable outcomes over the total number of outcomes. Okay, and then we're going to show an example here in a second. Complementary events. The complement of an event is made up of those outcomes of the sample space that are not in the event, usually written as this notation, not A. So the probability of a compound event, or a complementary event, is written like this: probability of not A, and that's always, probability of not A and probability of A should always add up to 1, so probability of not A is 1 minus probability of A. Alright, so let's take a look at this example here, and we'll work out the theoretical probability. A bag contains 4 red marbles, 5 blue, and 3 yellow marbles. 1 marble is selected. Find the probability that the marble is red. Okay, so the probability that the marble is red is going to be, well, there's 4 red marbles, and there's a total of 4, 9, 12 marbles. So it's 4/12, which is, if we simplify it, that's 1/3. Alright, next we have blue marble. Okay, so blue marble, we have 5 marbles, so it's going to be 5 out of 12, and you cannot simplify that. So probability of not red, you could write this: probability of maybe not R, not red, is going to be, well, actually we already worked out the probability that it's red, right? And this probability plus the probability of not red should add up to 1, so it needs to be 2/3. Probability not red is 2/3 in this case. Okay, a couple more. Example 2. Numbers 1 to 30 are written on counters and placed in a bag. A counter is drawn at random from the bag. Find the probability that a number is greater than 20. So how many numbers are greater than 20? Well, it's going to be 21, 22, and all the way up to 30. So that's actually, be careful here, that's actually 10 numbers there, okay? You can't just take 30, subtract 21, and get 9. You have to add 1 on, it's actually 10, right? So if you count them all up, 21, 22, 23, 24, all the way up to 30, there's 10 numbers there. So this probability is 10 out of the total 30 counters in the bag. So it's 10 out of 30, which equals 1/3. Okay. Probability of an even number. Well, there's 15 even numbers and 15 odd numbers, so probability of an even number is half. Right? And probability of odd is also half. Those have to add up to 1. Probability of a multiple of 3. Well, the multiples of 3, we have 3, and then we have 6, and then we have 9. I think there's going to be about 10 of them. Let's just double check. 12, 15, 18, 21, 24, 27, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of them. So it's 10 out of 30, which is 1/3. Probability of a number between 15 and 25. Well, we could write them out. That's going to be, well, it's going to be 16, 17, 18, 19, 20, 21, 22, 23, 24. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 out of our total, which is 30. And we can simplify that. We can divide them both by 3, and we get 3/10. So about 30%. So the probability a number is divisible by 5, a number that's divisible by 5. So numbers that are number divisible by 5, that's the same as the multiples of 5, right? So those numbers are going to be, we know it's going to be something out of 30. The multiples of 5 are 5, 10, 15, 20, 25, 30. So that's 6. 6 out of 30. Again, we divide by 3. We get 2 out of 10. We could divide by 6 there, which equals 1/5, or 20%. Probably a number is greater than 30. Well, there's no numbers greater than 30, so that's 0. Probability a number with 1 in it. So how many numbers have 1 in it? Well, one has 1 in it, and then we have all the from 10 to 19. Okay, that's again, that's 10 numbers. Then we have 21, and we have, oh, we don't have 31, so that's 10 numbers here, 11, 12, that's 12 out of 30. We can divide these both by 6 and get 2 out of 5, so 2/5, which is actually 40%. Alright, so next we're going to look at sample space and how we can calculate theoretical probability using sample space. So sample space is a set of all possible outcomes in an experiment. Alright, and there's a couple ways, or there's at least 4 different ways to write a sample space. Just a list, which is my favorite. Sample space diagrams, like this one right here, we're going to see in a second. Tree diagrams, okay, like we're going to do in a second, and Venn diagrams. Sometimes we can use Venn diagrams, not always though. Maybe when there's some overlapping cases, then we can have Venn diagrams to show the overlap. Okay, but I'm going to do each sample space here, talking about tossing 2 coins. So if I toss 2 coins, there's 4 different outcomes that can happen. So I'm going to list them first. You could get heads and then heads. You get heads, then tails, tails, then heads, tails, then tails. So when writing out sample spaces, heads and tails and tails and heads are 2 different outcomes, even though they're really the same thing happens. You have 1 head and 1 tail. But when we're talking about probability, we need to write all of them. Okay, so the order matters when we're talking about probability and sample space. So here's a sample space, a list. Okay, so you could write it out horizontally too with set notation as well, like this. Okay, so that's a sample space and the size is 4, right? Okay, next we're going to look at the sample space diagram here. So for the first coin, you could have heads or tails, and for the other coin, you could also have heads or tails. And then what we could do is draw some lines and look at how many points of intersection you have, basically. So I'm going to draw some horizontal lines here, vertical lines here, and here we have 4 points of intersection, so that's your sample space. Right here, this one is heads and tails. Here we have heads, heads. Here we have heads, tails, and there we have tails, tails. Okay. Next, we're going to look at this tree diagram. We're going to see a lot more of those later. And for the tree diagram, we can show the different outcomes here. So we have heads or tails, right, on the first coin flip. And then we could have heads or tails on the second one. Okay, so what we have here is we have a sample space of size 4. So this is one outcome, is heads, heads. And then we have, you know, if we go this way you have heads, tails. And we have tails, heads, and then tail, tail. So there's 1, 2, 3, 4 different branches that you can go through. So the sample space is size 4. So we can use sample spaces to work out probabilities. Okay, for example, let's look at what happens when we roll 3 dice. When we roll 3 dice, there's actually going to be 8 different possibilities. So we have head, 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 tail. We could have head, tail, head. We could have head, tail, tail. So that's 4. And then same thing, but with the first coin flip, tails. So tails, head, head. Tails, head, tail. Tails, tail, head. And all 3 tails. So there's 8 different possible things that could happen. So if you want to work out a probability, like let's say, what's the probability of getting 3 heads? Okay, there's one outcome with 3 heads, so that's just 1/8. What's the probability that altogether you roll 2 heads? Okay, what's probably rolling 2 heads? Well, there's 1, 2, 3. There's 3 total outcomes here with 2 heads, so that is 3/8. Alright, so you can work out that kind of stuff using the sample space. So you can have what's the probability of, let's say, 1 head or 2 heads. Alright, so which ones have 1 head or 2 heads? Well, maybe I should clarify there. Just 1 head and then just 2 heads. So it doesn't include this one with 3 heads. So 2 heads, 2, 1, 2, 1, 1. There's 6 total outcomes here with 1 or 2 heads. So the probability of getting 1 head or 2 heads is 6 out of 8, which equals 3/4 or 75% if you like percents. Okay, so you could also do sample space for like dice. So for rolling dice, you could have 1, say rolling 2 dice, you could have 1, 1, 1, 2, 1, whoops, 1, 3, and down to 1, 6, and then you have 2, 1. Notice 1, 2, and 2, 1 is not the same, right? And then you can write them all out. You'll get 36. So 6 and 6, you get 36 total possible outcomes. Okay, so then you can work out a probability, like what's the probability of rolling a sum of 3. So if you look at your sample space, sum of 3 there's only 2 ways to get a sum of 3, so that's 2 out of 36, which equals 1 out of 18. Okay, you can do something with sample space. You could do like 2 children in a family, or 2 children, a woman that has 2 children. The sample space is going to be, well, it could be a boy, girl, it could be boy, boy, 2 boys, could be a girl, then a boy, a girl was born first, then a boy, or girl, girl. So there's 4 different possible outcomes, so your probabilities are going to be out of 4. So the probability that, let's say the mom has a girl. Okay, you know that a mom has 2 children, what's the probability she has a girl? Well, there's 3 outcomes here with a girl, right? So that's going to be equal to 3/4 or 75%. Alright, what's the probability that a mom has 1 of each? Okay, so there's 2 outcomes here with 1 of each, a boy and a girl, so that's going to be 2 out of 4, which equals half, or 50%. Okay?